trust is the currency of modern software development. When a data scientist pulls a library from a repository, they are implicitly trusting the maintainer to deliver exactly what they promised. They are trusting that the code will not steal their data. They are trusting that the tools they use to build intelligence are not the tools that will destroy it. For years, the Node Package Manager ecosystem has been the backbone of countless web applications and data pipelines. But trust is fragile, and when it is broken, the consequences ripple far beyond simple bugs. On March 31, 2026, a significant breach was reported that shook the foundations of this trust. The popular HTTP client library known as Axios was compromised. This is not a case of a single developer making a mistake. This was a sophisticated supply chain attack where malicious versions of the package were released to the public registry. Specifically, versions 1.1, 4.1, and 0.30.4 were found to be infected. These were not minor updates. They were designed to slip past automated scanners and land directly into the projects of thousands of developers. The mechanism of the attack was particularly clever. The threat actors did not just modify the existing code of Axios. Instead, they injected a fake dependency named plain crypto.js version 4.2.1. This is a classic living-off-the-land technique. The compromised Axios library would fetch this fake module from external servers during the installation phase. Once executed, it delivered a cross-platform remote access Trojan targeting Windows, macOS, and Linux systems. A remote access Trojan is a piece of malware that allows an attacker to control a computer remotely as if they were sitting at the keyboard. They can type commands, steal files, and move laterally across a network without the user ever knowing. Now consider the specific impact of this on data science and machine learning operations. In these workflows, the build phase is where the magic happens. This is where raw data is transformed into trained models. Developers use scripts to pull datasets, pre-process them, and run training jobs. If the build environment is compromised, the integrity of the entire pipeline is at risk. The attacker does not just want to steal your passwords. They want to alter the intelligence you are creating. Imagine a scenario where a data team is training a fraud detection model. They feed the system historical transaction data to learn what looks like a scam. If the build environment is compromised by this Trojan, the attacker can intercept the training process. They can inject poison data into the training set. This is known as model poisoning. The resulting model might appear accurate during testing, but it will fail in production. It might flag legitimate transactions as fraud or, worse, ignore actual fraud attempts because the attacker has tuned the model to do so. Furthermore, the compromised library can exfiltrate training datasets. These datasets are often the most valuable asset an organization possesses. They contain sensitive customer information, proprietary research, or unique market insights. If a malicious script running during the installation phase copies these files to an external server, the damage is done before the team even realizes the model was built on compromised infrastructure. The data is gone, and the model is tainted. The reason this attack was so effective is that it blurred the line between trusted dependencies and active threats. Developers expect libraries to be static. They expect that once a package is installed, it does what it says on the box. This incident exploited that expectation. By using a compromised version of a trusted library, the attackers bypassed standard security checks. The code looked legitimate because it was inside a package that had previously been vetted. The malicious behavior was triggered only during the specific installation or execution window, making it difficult to detect with static analysis tools. Experts emphasize the severity of exploiting trusted repositories to distribute malware. It highlights a critical vulnerability in the Node Package Manager release process. It suggests that attackers targeted the package maintainer's credentials to bypass standard security checks and versioning controls. This is a form of watering hole attack. By compromising a popular, low-level utility library, the attackers achieved maximum lateral movement within software supply chains. Every project that depended on Axios became a potential entry point. Immediate action requires developers to audit their log files for specific compromised version ranges. A lockfile is a file that records the exact versions of all dependencies installed in a project. It ensures that everyone working on the project uses the same code. If you see those specific versions of Axios in your lockfile, you must assume your environment is compromised. You must rotate any exposed secrets. This includes API keys, database passwords, and authentication tokens. The Trojan may have already exfiltrated credentials from the build environments, so assuming your credentials are safe is a dangerous gamble. Future implications suggest an increased likelihood of similar attacks targeting popular, low-level utility libraries. As we rely more on automated pipelines for artificial intelligence and machine learning, the attack surface expands. We need rigorous dependency verification and mitigation strategies. One effective strategy is setting minimum release ages for packages. This means delaying the installation of new packages until they have been stable for a certain period. This gives time for the community to discover and patch vulnerabilities before they are deployed at scale. It is also vital to understand that security is not just about the code, it is about the process. Developers need to verify the provenance of every package they install. They need to use tools that can detect unexpected behavior during the installation phase. If a package tries to connect to an unknown server or access files outside its intended scope, that should trigger an alarm. We must move from a posture of blind trust to a posture of verified trust. The incident on March 31, 2026, serves as a stark reminder of the risks inherent in modern software ecosystems. It is not enough to know that a library is popular. We must know that it is secure. The compromise of Axios shows how a single point of failure can cascade into a widespread disaster. For data scientists and ML engineers, the stakes are even higher because the output of their work drives business decisions and automated actions. A poisoned model can lead to financial loss, privacy violations, or operational failures. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.